Greetings, Earthlings! Today we have a new HP toy. Well, it's not new. It dates from the 1970s, but it's new to me. This is a 5304A timer counter. Actually, it's 2 units. There's the top half here, which is a 5300A measuring system, which is a 6-digit display and also includes a 10 megahertz oscillator. And then this plug-on here, and there was a series of plug-ons, various counters and timers and such. This happens to be a 10 megahertz timer counter. Like I said, there are other ones in the series. So let's power it up and have a look here. Have it in self-check mode, where it's measuring the cuteness factor on a scale of 1 to 10. No, actually, this is measuring the 10 megahertz clock crystal, using the clock to measure itself, and it should be 10.0 plus or minus 1 count, which it is. There is one burned out indicator. It looks like there should be a hertz indicator over here. And then what I've done is I've got it, the output. Output? What do you mean output? It's a counter. No. The oscillator output is connected to the other oscillator over there. And that is showing, that one has an oven-controlled crystal oscillator in it. So, and it's accurate. It has more digits. So it's showing that my nominal 10 megahertz is 10.0000123 megahertz. You can tell it's 10 because the overflow lid is set. So the overflow light is on, LED there. And this will vary. You know, I've just turned this on. As it warms up and as the room potentially warms up, we'll see this one change because it's not compensated. It's not temperature compensated and it's not oven controlled, so it'll vary. But for a 6-digit oscillator, it's probably good enough. What I can do, I have another 10 megahertz oven-controlled crystal oscillator. And so what I'm going to do is I'm going to plug that into the 5316. And we should see that they agree pretty closely once it gets an accurate count here. I said, well, I've got to adjust it, haven't I? No, that's fine. That should be okay. It's blinking. Let's see if we can get... There we go. Okay. So they agree pretty closely. They have drifted a little bit apart because they used to agree. You know, they used to be spot on. But 5 counts there. How many ppms is that? I'll figure that out. But it's a very small number of ppms. Okay, so let me take now the oven-controlled crystal oscillator, 10 megahertz. We'll disconnect it from this guy, and we'll connect it here. And we should see. Is it actually doing anything? No, because it's in self-check mode. There. 10.00009. Okay, plus or minus 1 count. That's pretty good. Okay. That's just measuring frequency. And actually I could go, watch this. I can get an extra digit out of it there. Oh my. And it's off by 2 counts. Oh, I don't like that. Let's go back to auto. Okay. What else can we do? Well, since we're in HP cuteness mode, let's bring in this other HP here. And I'm going to turn it on. All right, we'll go with that. 3310B function generator, which is from the HP Cute line of function generators. And we'll hook this up. And I got it outputting approximately 1 kilohertz now. This is not going to be as stable. It doesn't have a crystal in it, but so 0.98K. Well, that's not very interesting, is it? I can get more digits out of this. Nice. Oh, I'm going the wrong way. Okay. Hertz. The Hertz light should be on right there. Okay. And we've got to wait 10 seconds. So it's saying 979.7. Again, both of these, neither of these has warmed up, so that'll drift as we go. What is that in, microseconds? No, it's not. Okay, there we go. It's about 1 millisecond. Yeah. So, okay, so we can measure frequency. We can measure period of the A signal. It also has a B input. So it can do time interval A to B, which is quite useful. Which that other one can do as well. That other one can do all the same things, but to more digits. So what good is this in this day and age? Well, it's I really like the display. How's that? It might be good for monitoring the output of an analog function generator. I don't know. It only goes to 10 megahertz. Not good for, FM radio work, certainly. So I guess what we can do at this point is open it up. I'm not going to demonstrate the time interval stuff. Trust me on that. But let's have a look at it here. How it's constructed and whatnot. Okay. And so it's got these pull tabs which separate the two sections. And again, the bottom section is called a plug-on, not a plug-in, because it plugs onto, there we go. It's got this one big honking connector that looks like a Centronics printer connector between the two, okay, to connect them. So here's our counter and display section. You can have an external oscillator, so it could run off of that crystal control or oven controlled crystal oscillator if I wanted it to. And then this is the plug-in section, and let's see if is it possible to remove this card. Looks like it's screwed down. Well, maybe not. No, that'll come off with it. Okay, there we go. Uh-oh. No, the front panel, there's some stuff that looks like soldered to this board on the front panel. Oh, no, the whole thing. Oh, I lied. Okay, the whole thing lifts out. And there it is. And then it has some TTL and some DTL circuitry. It's got a mil-spec 5410. There's a 7400, 74 LS74, 7408. Well, maybe there's no DTL in this era. These are date codes, 1976 date codes. So maybe they had eliminated the, well, I don't know, because there's some here with like HP part numbers that I don't know what they are. Oh, there's a couple of ECL parts in here too, as part of the counter. So, but as we saw, it's basically functional, so it doesn't really need anything. Anyway, that's it. This one comes apart as well, but there's a screw. Oh, actually, let's see. Caution, remove screw before disassembly. This screw is bizarro because it was made off center. The head is off center, which is very un-HP like, but I'm sure they didn't make their own screws. It's off center. Is that weird or what? Let's have a look at the display in it. As long as we're in here. I said, let's take a look at, yeah, oh, you know what? Okay. I don't want to lose this lock washer. Okay. There we go. Sheesh. Okay. So these parts are probably irreplaceable should they ever go bad. I'm not sure what these other bits are. That's HP molded in, so that's probably a custom part. HP. Yeah. When this goes bad, if any of these things go bad, it's probably dead at that point. There's a crystal oscillator. That's the crystal right there in this can. But anyway, pretty simple. That's probably just a counter or something there. And then this is the display drivers. I don't know. You got some transistors to drive the actual LEDs. But there you go. That's the HP 5304A and the 5300A measuring. What do they call it? Measuring system. Okay, measuring system. And the 5304A timer counter plug on, for what it's worth. And there you go. I replaced the LED. It turned out it was a bad LED. So this dates from the mid 70s. So these are probably fairly early LEDs. I don't remember when LEDs first came out, but there's the old one. I didn't have an official HP, but as you can see, hopefully it's pretty close. I just used a regular old generic red LED in there.